All right. Let me just get my chat up here. Whoops. Hang on, folks. Okay, so last we left off here, we had a basic first-person controller using the character controller, running around and jumping. There we go. All right, so today I think I'm going to do basic AI with using coroutines as the state management. One of the things that's often challenging about AI is state management, creating a state machine to transition through different states and controlling the transition. Okay. Oh, so last we left off here, we had a, and so I'm going to use coroutines as with a state management solution, and we'll use Nav Mesh agent, the Unity's AI nav controller, to navigate an environment. So the first thing you'll want to do with your world to prepare for Nav Mesh agent is to generate a Nav Mesh. The main thing to be sure of is that your world and your world objects are marked static. That will make them work correctly with the navigation mesh. It also does performance improvements for rendering and stuff. So making anything that doesn't move in your world, particularly world geometry, terrain, things like that, making them static is always a good idea. So I'm going to make a root object here. I'm going to call it world. Just an empty game object. Make sure it's at 0, 0, 0 and scale 1, 1, 1. And then I'm going to put all my world geometry under that root. So my ground plane, my buildings, and my ramp. I'm just going to throw them all under world. And then I can go up here in the corner and check static. It'll ask me, do you want to change them for children as well? Change that flag for children as well? I'll say yes. And now everything is marked static. Now we want to build our nav mesh. So if we go window where is it? Yes, AI. Where is AI? Here it is. Navigation. Get a tab over here in the inspector. If you go to the bake button here, we have some properties. So here's the default sort of what it assumes the agent typically is, and this is fine for human-size agents. This will do fine. One thing I like to do is go under advanced to height mesh. Oh my God, it sounds like my PC is taking off here. And check height mesh here. This will increase the accuracy of your nav mesh agent contact with the ground. I found often if that's not checked, they're a little bit above the ground. I find generally speaking this is worth doing. And then bake. Usually only takes a few seconds, and then when you're on the navigation tab in the inspector here, you can see the nav mesh in the scene view. It'll show you the geometry, so you can make sure that, for example, you can see it here. It's going up the ramp. This is using nav mesh agent settings as to say the slope, which usually, as a general rule, if you have player character controllers, you kind of want to match those parameters, the height and things like that, so your player is maybe the same size. And then there you go. And then if you want to rebuild, if you have to rebuild, like say for example I move a building, just as a demonstration, say I move that building, you can see the nav mesh doesn't automatically update. I'll want to clear or just simply rebake. And again, it's such a small scene that it's very small. I'll just do that change, get the building back where it was, and bake again. There we go. Okay, so let's start our AI script. So I'm going to go into my script folders, right click, and create a new C# script. And this one I'm going to call unit AI. And I'm going to open that up in Visual Studio. here we go. So the first thing I'm going to do is throw this class into the Brengine namespace, just like our other Brengine classes at this point, like so. I'm also going to go and put using Unity Engine AI to get the AI system included. And then finally, I'm going to make sure that unit AI is derived from the unit class. And then I'll remove the comments and hook up the virtual function overriding. So these need to be public overrides, call base start, and ditto for update. Calling base update, like so. And now, like my unit player class, which I'll just open up quickly, I'm going to use a required type of character controller, I'm going to use the required component directive as well. And I'm just thinking to myself, when you have a player character navigating the world with AI that use Nav Mesh agents, you usually want to put a Nav Mesh agent on the player, which is not active. It's disabled. Well, it's not disabled in the component sense, but you've turned off update position and rotation. And so you can move manually that Nav Mesh agent around with the other Nav Mesh agents. The one on the player, you want to move it manually so that the other agents are aware of the player as an agent. They will path around it, avoid it, that kind of thing. So I'm thinking I might want to make the Nav Mesh agent a required component of the base unit class. There might be some cases where I might not want that to be the case, maybe for like turrets that don't move but still have a combat AI running or something like that, in which case they'd be Nav Mesh obstacles. So I'm thinking what I'm going to do is I'm going to make the Nav Mesh agent member a member of the unit, but I'm not going to make it a required component. That way you can assign the unit AI and you don't need an agent. And then wherever I use the agent, I'll just null check it in these cases to make sure that there is one. So with that theory, I think that's the way to go, because I do want to have a Nav Mesh agent on both AI and unit player. So I'll make it optional, and then when it's there, it'll be used. So I'm going to go to class unit, and I'm going to add a private. Oh, so I'll need to add using Unity AI here as well. And I'll add a private Nav Mesh agent, and I'll call it agent, and I'll initialize it to null. And then because this is in unit here, I'm going to grab it, a reference in awake. So agent equals get component, Nav Mesh agent. There we go. So now I've got an agent member in the base class. I will first we'll do some AI work, and then maybe towards the end I'll come back to do, or maybe it would be better to do the unit player stuff first, because that's a little bit easier. Let's do that. It'll be quick. So what you want to do, again, in this, when you have a player character when you have a character controller moving around the world with AI agents, you want to have an AI agent or a Nav Mesh agent on the player character, which you move manually, so that the other agents are aware of it as a Nav Mesh agent and will avoid it and things like that. So I'm going to go to my player object, and inspector, and add a component of type Nav Mesh agent, like so. Now again, I'll just have a quick look at this here and make sure that it looks good. Its offset is correct. Yep, that looks good to me. And again, this Nav Mesh agent will not actually be moving. We will move it manually with the player controller. So I'm going to make sure that that works. I'm going to go into unit player. We'll have we should have a reference of the agent thanks to the subclass. So down where you move your controller, just throw in a function. I'll null check it just to be careful. If agent doesn't equal null, then agent move, basically the same move that you applied to the controller. And I think if I don't save this, I may be able to demonstrate. Oh, I see. I'm getting an error here. I've defined the agent as a private member. It should be protected. So if I drop back to unit, I should change this to protected. There we go. Always make sure your privates are protected in public. Okay, so here we go. So now I think, before I save that change to the player, make sure I save the unit change, yes. So we may see the Nav Mesh agent not move, which would be good to demonstrate why this is important. Oh no, it moves. I guess because it's on the controller, but nonetheless, it's important to do this move. So I'll save this change. And then back here, we can see that it's working correctly. So now I'm moving a Nav Mesh agent manually around the world. This is good. Okay, let's get to start on our AI. I'm just going to copy my little player primitive here and turn it into an AI. So I'll just click on it, Control D to duplicate it. I'll rename it, let's call it Unit AI for now. And I don't need a character controller on this. Actually, I don't even need a unit player script. I really just wanted the visuals. So I'm going to remove the unit player and the character controller. And I'm going to throw my unit AI on there, like so. Trying to get it above the agent. There we go. Okay. And I need to add a Nav Mesh agent manually now. Oh, sorry. It's already there, so that will do fine. Okay, now let's drop back to our script here. Unit AI, I've got the agent. Okay. So I'm going to use coroutines as a way of creating my state engine for my AI. If you're not familiar with coroutines, you can think of them as kind of a Unity flavored multi-threading solution. So it's not genuinely multi-threading in the sense that you're not running two processes in parallel simultaneously. It's a task swapping solution. So basically, it fires a function, that function yields to the system when it's finished doing its processing, and then other systems get ticked, and then the next update or whenever you've requested, you'll see what that means. The function is returned to and continues execution from the point of the yield. It's very useful. The nicest thing about it is, from a programmer point of view, you can approach it as if it is a multi-threaded function, in the sense that the function feels like you're staying in it. So if you have a while loop, while true say, that's an infinite loop. It will stay in that loop until you exit the coroutine. This is really nice for state management because once you've entered a coroutine, you can stay in it easily until you're ready to transition. That's one of the difficult parts of managing state transitions. So using stacking coroutines in this way gives us a lot of sort of state management functionality for free. You'll see what I mean. I'm going to start by, right in start, I'm just going to start coroutine, and I'm going to start a function called think. And then we'll go down here and we'll add the think. I'm going to make a private function. Coroutines need to return an I enumerator, and it's called think. It takes no parameters. And when you write a coroutine, until you've put in a yield statement, you will have an error. You need to return something. So I'll just throw yield return null in here. Now my think is going to be my main sort of state switchboard, if you will. So it will be responsible for entering states when appropriate. And it should execute like in a while true loop. So I'm always thinking, as it were. So I think about what I want to do. I do what I want. I do that thing until the conditions for that situation have changed, in which case I return, and then I think again, and I'll reevaluate the scenario and possibly execute a new state or a new coroutine. So to prime the pump here, I'm going to go while true in this function. And then I'm going to throw this in here like so. Now this is an infinite loop. I will, once think is started, I'll just think forever until my game object is destroyed or disabled. So right away, if we drop back here, let me get my AI out of here, and just for the sake of argument, let's throw a duplicate cyan, and I'll throw a pink material on my AI here. Or magenta. That looks nice. Let's rename. I'm going to go for a nice pink. Here we go. Lovely. And I'll throw this on the capsule under the AI. There we go. So if I run this, I should have no errors, but in theory, this AI is thinking. Let's throw a debug statement to see how that works. Debug log, thinking, like so. Let's give that a case. Actually, you know what we could do is we could put this in our debug. If debug, and remember debug is a little boolean on unit that I can turn on and off in the inspector. I'll demonstrate that here. Here's the debug bool. So if I run this now, I don't see any input. I don't see any debugging, but if I turn on debug, there I can see now the AI is thinking. If I collapse, it's all the same line, so I can collapse this down to 1, and then I see the count here. So you can see that each frame think is getting ticked. That yield return null yields to the next frame, and then at the next frame, it will execute that function from that point. So basically what's happening here is each frame, on start, think starts. The think coroutine is started, and then while true, if debug, I log the thinking statement, and then I yield return null, which yields to the next frame. It returns processing to the rest of the system. Then the next frame, it just goes while true, that's still true, debugs again, logs the thinking, yield return null. So basically it's logging thinking every frame right now. That's basically all it's doing. Let's just stop this here. And I'll turn off debug. Oh, okay, I turned it on at runtime, that's fine. Okay, so right now, I'm just gonna start with basic wandering. We'll just get the AI wandering randomly around the map. So I'm gonna start a coroutine called wander, like so. And then we'll add that coroutine, much like think, so maybe I'll even just copy that and call it wander. And in here we'll go, and you know what, I'm just going to copy this whole thing, throw it in here as a stub, and we'll just change this to wandering. Get rid of that. Okay, there we go. Okay, so I'm just going to thinking of a few variables I want to have associated with wandering that we'll want to add here. I am going to say, let's do a public float wander. Let's say wander distance minimum equals 5 units. Copy that. Say wander distance of maximum, say 10. And then another thing I like to do is we'll copy both of these and say wander time min and wander time max, and I'll just leave them as 5 and 10 is fine. Another couple of things I like to do for wandering is to have a public bool. Let's call it tether, and we'll initialize it to false. And then a private vector3 that is my start position, and I'll initialize it to vector3 0. And then, so start position is the position I started. So where I was spawned or where I was placed in the level, right at the start, first thing we'll do is grab our start position. So we remember where this AI started. So I'll go in start position equals transform dot position, like so. So now this AI will remember where he started. Okay, now down in wander. So the way I want to approach this is pick a random position to wander to and wander there until some time elapses. I might reach the position first, or wander time might elapse. Having both of those, both a random wander distance and a random wander time, gives you a nice kind of random behavior in the sense that your AI may change direction while he's wandering, or she might stop, think for a moment, and then choose a new direction. So you get nice kind of random wandering behavior that isn't just like I'm always moving. Sometimes I'll pause and then I'll start moving again. And sometimes I'll change direction while moving, and just different behavior. It looks more like random, aimless wandering, which is what we're going for. So to approach this then, the first thing I'm going to do is choose a wander destination. So I'm going to go vector 3. We'll call it, first let's choose a direction that I want to wander. Wander dir equals new vector 3. Random range for the x value between -1 and 1. I'm not going to change my y, and then I want a random direction on z as well. Like so. Now what we could do is, now we've got a vector with a random x between -1 and 1 and a random z between -1 and 1. So what we can do now is scale that by a random value between our minimum and maximum wander distance. So I'll go vector 3 wander destination, or dest, equals wander dir times random range between wander distance min and wander distance max, like so. It occurs to me another thing I might want to do is maybe I have AIs I don't want to wander, like a guard or something. He's just posted somewhere. I want his AI thinking, want it active, but I don't want him wandering. So I'm going to give, and maybe I want characters who might wander. There's a chance they might wander, whether that's 100%, 50%, or 0, which might be no wandering. So I'm going to go back up to the top of here and add a new variable right at the top called public float wander chance. And let's give it a default of 1, 100%. The wander chance will be between 0 and 1. So now in my think, I might say if my wander chance is greater than 0, there's a chance I might wander. I should start my wander function. So if wander chance is greater than 0, then wander. Within wander, I'll say here, where I decide if I want to wander, I'll go if wander chance equals 1 or a random range between 0 and 1 is less than or equal to the chance to wander. So, and then I'll throw all this stuff here, like so. The idea being here, if I have a 100 or 1% chance to wander, or a random number between 0 and 1 is less than or equal to wander chance. So if I say wander chance of 0.5, 50% of the time. Wander chance of 0.75, 75% of the time. Wander chance of 1, 100% of the time. Always wander. Okay, now we get into the tether. So if I'm tethered, if I've checked that Boolean for tether in the inspector for this particular AI, I want them to stay within their wander range of their spawn position, of their start position. If tether is off, I'll allow them to wander freely. So basically, if you're tethered, every time you choose a wander destination, it's offset from your start position. If you're not tethered, it means your new wander destination is offset from your current position. So I might wander far away and then wander still farther. Whereas if I'm tethered, each time I wander, it's within the range of my start position. So the way I'll do that is I'll go if tether is true, then wander dest plus equals start position. Else wander dest plus equals transform position. Now remember that wander dest is just a value between the minimum and the maximum wander distance. So it might be between 5 and 10 only. So currently, unless I add my start or current position, it will always be within the origin. So you want to either offset it from your start position or your current position to get somewhere else in the world within range of your start or current position. Now we can go agent set destination wander destination. This will get the agent to start navigating towards that destination. Now what we want to do is basically just do that until our wander time elapses. So first we'll choose a random wander time. So we'll go float wander time equals random range between wander time min, which could be 0, wander time max, like so. And then we'll go while wander time is greater than 0, wait a frame, yield return null. So wait until the next frame, and then subtract the frame time from wander time. Minus equals time dot delta time. So basically, each frame, I'll check to see if my wander time is greater than 0. If it is, wait a frame, and the next frame, I'll subtract the frame time and then check again. So basically, we choose a random direction, we scale it by a random distance between our min and max wander distance. If we're tethered, that's offset from our start position. If we're not, it's offset from our current position. Set the destination on the agent. That will start the agent moving there. Oh, lost my camera, just a moment. Hang on. Sorry about that. I need to figure out how to disable the auto off. I will get there. Where was I? Yes, okay. So then wander there, choose a random time between wander time min and wander time max, and then wander there until it expires. Now, I might reach that position. The agent may reach the destination before the wander time expires, in which case I'll just stand there for a second or whatever until it elapses, and then choose a new wander position. Or it might elapse while I'm still moving there, in which case I'll choose new position. And that's where you get like the behaviors that I described earlier. Let's save this and have a watch here, because I believe we're good to go. There we go. Oops, wait a sec, something ain't right. I believe, let's have a look here. Let's turn on debugging, see what that tells us. It looks like it's not waiting the wander time. Min and max, min and max. Yeah, she looks like she's wandering every frame. Yeah, I think something strange is happening. Hang on a sec here, let me have a look at this. Thinking, wander. Oh, of course. Each frame, my bug here is that each frame I'm starting a new wander coroutine. What you really want to do here, and this is very important, I'm surprised I missed this. This is very important for your state control, is you want to yield, return, start coroutine. This is actually the whole point of this state engine. The idea here is that think will start a coroutine and wait for it to exit. So once I'm wandering right now, I will always wander. Later on, we'll put in conditions to change that. But right now, you want think to start the coroutine and not do any thinking until that coroutine returns. This will fix it. There you go. So the problem there was just by calling start coroutine, each frame think was starting a new wander coroutine. So that's something to keep in mind. You can start multiple copies, if you will, multiple instances, whatever term you prefer, of a coroutine. So when you yield return start coroutine, it won't return until that coroutine exits. I hope that's clear. Coroutines are a little bit hard to wrap your head around unless you're already familiar with multi-threading. But start coroutine will start a coroutine and it will go off and run on its own. Yield return start coroutine will wait until the coroutine returns before continuing. It can be really useful to nest coroutines, but you need to be very careful because it's easy to accidentally make mistakes where you've got multiple copies of coroutines, or it's not clear that you have multiple coroutines running. So you need to, it's tricky, granted, but it's super useful once you've figured out all the caveats. So now we have this AI wandering around our map. She's wandering very quickly. One thing we would want to do is set the agent. Well, right now she's wandering at the default agent speed of 3.5, which is pretty fast for a wandering behavior. She looks very intensely wandering. So what I want to do is at the beginning of my wander function, first thing, I'll just set my agent speed to walk speed. So she only walks. She only wanders at the walk speed. There we go. The other thing is maybe set my angular speed to my AI turn speed. I mean, in theory, turn speed is kind of redundant. I could just set my angular speed as I like, but I do kind of like the idea of like making my unit AI, kind of fully aware of all of its parameters and not rely on things set in the inspector or in other components. I would rather tell the agent what I want the AI speed to be than set it on the agent. That is very much a personal preference thing. I don't think it's wrong to do it otherwise, but it's just the way I prefer to go. So usually right at the beginning, after I get the agent, which is done in... My camera keeps turning off. Oh, the battery's died. Ugh. I just replaced that thing. Give me one moment here. I'm going to change my battery. Okay, there we go. We're good? Yes. All right. Where was I? Gosh. I don't know. Let's have a look and see what this AI is doing here. Excuse me. Right. Oh yes, the turn speed. Right. So right after I get my agent in unit start, I'll go if agent does not equal null. I'm just making sure that I do in fact have one. Agent angular speed equals my turn speed, which is defined in unit here, like so. So now the AI will move and turn at the speeds defined in the unit AI component instead of setting it directly on Nav Mesh agent. If we run it, you can see they get changed at start. Speed 1, which is walk speed, and angular speed 90, which is turn speed. There she goes, and she should avoid me if I get in front of her here. Walk around me. There we go. That's because I have Nav Mesh agent on me, which is good. Otherwise, they move right through you, which is not so desirable. There we go. That's basically wandering. If there's any more behavior that might be interesting on wander, let me know. But this has always been adequate for me. Let's you know what we could do too if we go edit preferences. No, sorry. Edit project settings. Time, and I'll just, for debugging purposes, we'll just increase the time scale to 10. So basically the game is running 10 times faster than it should, just to see the behavior of, say, tether. So right now she's not tethered, so she'll wander far from her start position. She's not particularly doing that, random being what it is, but there you go. Now, here, let me pause and move her over here. And now you can see, now she's wandering in this area. If we turn on tether, we can do this at runtime even. She knows her start position, so now she starts to wander around the start position. She goes back there, essentially. She chose a destination around there. If I turn it off again, and I think if we maybe wait a little while, you can see now she's wandering out again. So that's the effect of tether. It can be really nice to have like AIs wander around their cave or their house or whatever, their start position. Like so. And then the values you can tweak is how far they wander, how long they wander, things like that. And you can get some interesting behavior. So for example, if you reduce the wander time, you get a character who seems like really edgy or, you know, nervous or whatever. They're constantly changing direction and looking around, you know, like they're alerted or something like that. They get that behavior. If it's very long, then they tend to, you know, they'll wander long ways, you know, like meandering. So you can get a lot of interesting behavior just from a couple of cool little variables, which is always nice. Another thing I think is worthwhile doing at this early stage is path following. Let's set up a path around our little town, and we'll get the AI to go on a circuit to do patrols or things like that, or even work schedules, however you want to, you know, think of that. Path following is obviously a useful thing to do. So I think maybe just for interest's sake, I'll make some more buildings here. Increase the interest of our little town. What's the easiest way to do this? Let's do. Oh, that's one thing to be careful when you have these kinds of things is when you click on the visual, you'll get the cube. I actually want the buildings here. Before I get too much ahead of myself, I should make these prefabs, but whatever. Let's just grab the top two, duplicate them, move them out to Z20, say, or I guess 30 up there. Likewise with these two, which is 2 and 3 by the looks of it. Dupe those, bring those down to -30, and then I'll grab, what is it here? 1. So I want these 4 here. Which of these guys? Oh, this is hurting my brain already here. I lost it. Let's grab which one's here. Oops. Building. So building 3, 5, and 7. 7. Dupe these, move them out to X30, and dupe them again. It's not letting me. Dupe them again, move them out to -30. There we go. And then I should rebuild my nav mesh, so bake. There we go, nice and fast, good. Okay, let's start just by defining our path here. So I'm going to create an empty game object, and I'll call it path. And make sure it's at 0, 0, 0. And then under that, I'm going to make a new empty, and I'll call it path node. And I'll call it 1, just so Unity's duplication renaming works nicely. And I'm going to turn on one of these little game object labels, tags, whatever you want to call it. Choose the blue one. Now I can see in the editor here, if I zoom in close enough, now you can see it has a little label. This is handy. I want to see it a little bit further away, so if I go to gizmos, the little arrow here, and increase the size of 3D icons, there we go. Now I can see path node 1. Good. So this guy I'm going to move out to, I'm holding control to snap, and I'm going to move it out to -2020, right in the middle of the road there. Then I'm going to dupe it, move it to, or sorry, that's -20, 20 on the X, and then grab them both, dupe them, and move them down. And it looks like I got 3 and 4 kind of reversed. I want to have like a nice clockwise path here. So I'll just drag 3 over here. Suppose I could just rename them, but whatever. And I'll drag 4 over here, like so. There. Good. There we go. So now I've just got a little path called path, and I've got some path nodes. So the way I'm going to approach this is I'm going to, there's a few ways to go about this kind of thing, but the way I'm going to do it is have a path that stores references to these transforms that are its path nodes. And that's essentially it. So a path class that stores path nodes and has some useful functions. So I'm going to create a new C# script, and I'm going to call it path. Open that up. And I'm going to throw it in the Brengine namespace. Like so, get rid of my comments. Don't need those. There we go. Okay, so the main thing is I'm going to want to have a list or an array, what have you, of the path nodes in this path. I'm going to use a list. So I'm just going to go public list of transforms, and it's called path nodes. Path nodes. There we go. And it's public, so it's in the inspector. Now if I drop back to Unity, click on my path, wait for the inspector to join us. What's going on here? I'm going to turn off lighting. It's baking lighting constantly. Let's go to rendering, lighting settings, and turn off auto generate. There. Okay, where was I? Right. So put my path script on my path object, and then there's the path nodes array. One thing I can do, this is nice, I want to assign these, right? So as soon as you click on it, you've selected it. So that's less than ideal. So what I want to do is go to path and then choose the little lock icon. That'll lock this selection in my inspector. Now I can choose one and shift click 4, grab them all and drag and drop them into path nodes, doink, and it adds them. Make sure they're in the right order. 1, 2, 3, 4 looks good. Size 4 looks good. So now I've got my 4 path nodes assigned to my path. So let's go to the AI now and add pathfinding. Oh, first, let's add a couple of these utility functions to path. I need 2. I want to know the closest path node to me. So when I start navigating, I go to the closest one instead of like going to 1, which might be farthest away. This way I can have AIs at different points in the path and they don't all go to 1 and then start going around, right? You just want them to start at the closest one. And then the next one is get next, which would say I've reached this path node. What's the next one? So there's 2 functions then. They're public. They return a transform. One is called get closest, and it takes a position, vector 3 position. And the other one is called public. It's also returns a transform. It's called getNext, and it takes a transform, which we'll call current. Like so. We're getting errors because there's no return values on these yet. That's absolutely fine. Brenny needs to take a little loo break. So please give me one moment. I'll be right back. Okay, I'm back. All right, sorry. Okay, so let's continue with our get closest here. Basically, this just takes a position and returns the closest path node. So we'll start by going, I need a local transform reference. We'll call it closest equals null, and float distance equals 0. And then we'll go for each transform path node in path nodes. Now the first time, the first path node, closest will be null. So we'll go if closest equals null, and then for subsequent ones, distance will be the distance to the closest path node. So the first one will be the closest one, and then we need to calculate that distance. So we'll go first we need to calculate the distance. So first we'll go float d equals vector 3 dot distance between this path node's position and the position that was passed. There we go. So now if closest is null, meaning we're on the first path node in this path, or d is less than distance, then this is the closest path node. So closest equals path node, and the new closest distance equals d. That's basically it. And then here after this, return path node. That's it. Oops, sorry, not return path node, return closest. There we go. Yeah, return closest. There we go. So just to be super clear, we get a position, we say, okay, closest is null, we don't have one yet, and the distance is 0, we don't have one yet, for each path node in path node. So we're going to do this for each one. Get the distance to this path node. If the closest is null, this is the first path node we're looking at, or the d, the distance for this path node, is less than distance, which is the closest distance, then closest equals this path node and distance equals d. And then the next time we come through, it'll calculate a new d, maybe it's less than distance, that's the new path node or whatever. If the first one happens to be the closest, basically nothing will happen. And then finally at the end, after we've gone through all the path nodes, we return whatever is the closest. In theory, if this path contains no path nodes, it will return null, which is kind of to be expected. Get next is past a path node, which we assume to be in path nodes. And so it will go, okay, given this path node, give me the next one. So the first thing we'll want to do is figure out what index the past path node is. So we'll go int index equals path nodes index of current. If current say is null, or your current isn't in your path nodes, index will be -1. So that's an error condition. So we'll just go if index equals -1, return null. We don't know what to do. I mean, in theory, I suppose I could return one of the path nodes, but this is more of an error condition, so I'm not going to do that. Now what we'll want to do is get the next path node. So we'll just increment index plus. If the current one is the last one, we want to loop back to the first one. So we'll go if index is greater or equal to the number of path nodes, 0 base, so if it's equal, it's the number. Then cycle back to the first one, like so. And then finally return path nodes at that index, like so. I think that'll do it. I believe that will do it. Okay, so let's implement path following on our AI now that we have path. I like to do two things. I like to say you can assign a public path, and it's called path, and it's public so it can be assigned in the inspector, or you can assign a transform and call it path node. There's two reasons for this. One is I need to know what my path node is. So if I have a path, I need to get the path node from it, and then path node will be the next path node that I'm navigating to. So we're going to need a path node reference regardless. The other nice thing is I might assign just a path node, and instead of a path, so path might be null, but I've assigned a path node, and then my character, my AI, can go to the path node, and once it's there, it just nulls it and then wanders or something. But the idea is I want to use the path system to be able to say, okay, you go to this point, you go to this transform. Maybe it's a path node, maybe it's a building, it could be just an invisible transform somewhere in the world. But basically, use the path following mechanism to get a character to go to a point. Okay, so now in Think, this is where the priority of things start to become a question. So wander typically would be like your lowest priority, let's call it state, AI state. So if I'm doing nothing else, I wander. And if my wander chance is 0, I won't even wander. So if I've got nothing else to do, I'll just stand there. If my wander chance is greater than 0, there's that chance that I might wander. This is the lowest priority state. Immediately above this would be path following. Above that would be things like combat or tasks that you've been assigned by the player or who knows what. But you basically kind of think of what's, build up from your lowest assumption. What's the base thing you want to do? So wandering is my last thing. So I'm going to go in Think here. This is where I'm thinking, what do I want to do? I'm going to go if path does not equal null or path node does not equal null. Then yield, return, start coroutine, follow path. And then I should add here, else. So if I have a path or a path node assigned, start a coroutine to follow that path. Else, do I wander? If wander chance is greater than 0 and I don't have a path node assigned, like if none of these conditions are true, I'll basically just yield this frame, and then next frame I'll think again, which is fine. I don't think this is a very cheap function. So thinking every frame generally isn't necessarily a bad thing. I could yield return, wait a second or something. We'll get there, but this is generally fine. It's my belief that you don't optimize code until you've shown it to be a problem. I don't optimize as I code. I try to write code as simple and clean and as little of it as possible. And then if it needs optimization, if it's demonstrably slow, measurably slow, in the profile, it says this function is slow, then I optimize it. There's lots of optimization opportunities already. We'll just keep them in mind and revisit them when they need to be revisited. Okay, so follow path. So I'm just going to grab this header here. We'll have a private. It returns an IEnumerator, and it's called follow path, like so. Okay, so the first thing I want to do is figure out what path node I want to go to. So I'll go if path node equals null. So this is if I don't have a path node assigned. If that's the case, the only way I could have got in here is if path was assigned. So I can assume then that path is assigned. So I'll go path node equals. The nice thing about this too is you could like assign a path and a specific path node. So if you didn't want him to go to the closest one, you wanted her to go somewhere else to this path and then start following the path, you could assign the path and the path node, get like more control that way. Don't go to the closest one, go to this specific one and then start your path. Path node equals path, get closest. This will be our assumption and to my current position. So if I don't have a path node assigned, get the closest one. Now here I'll go while path, tempted to jump ahead a little bit here, but I think I won't. So while path does not equal null and path node does not equal null, so while both of these conditions are true, just tell my agent to go to the path node position. Now, one thing that is a little bit challenging in Unity, and it is a little bit annoying, is knowing when an agent reaches their destination. It's surprisingly tricky, but I've managed to kind of arrive at what I think is a good solution that works in the cases I've seen and isn't too laborious. One thing, you do have to, make a couple of concessions. So one thing I like to do is drop back to my unit AI. Turn off lock in the Explorer or in the inspector. On the nav agent, I set stopping distance to 1. Stopping distance is basically how close does the AI have to get to its destination to consider itself there. 0 means it has to get like exactly to that point, which is maybe fine as a default, but I find you don't really need that kind of granularity. And as a matter of fact, sometimes when there's a little bit of noise in the AIs, they look a little more natural. So if you've got like a phalanx of them, a formation like 5 by 5, if every single one is like exactly in the right position, it looks a little artificial. Whereas if there's a little bit of noise in there, it looks a little more realistic. So I'm usually fine with the stopping distance of 1. The nice thing about that is it makes it a little easier to check our state. So one thing we want to do is when you assign a path to an agent, there's a little time there, it can vary depending on how many agents you have, where the path may not be calculated. So it might take a few frames for it to start moving as it's calculating a path. You usually only see this when you've got a lot of AI. Probably won't see it with only a few, but nonetheless it can be an issue. So when the distance to your destination, or which is available on the agent, is less than your starting position, then you're there. So those are the two conditions we want to check. So I'm going to say something like while agent path pending equals true. So this is while it's calculating its path and it hasn't started moving yet. We don't want to consider ourselves there. Or agent remaining distance is greater than agent stopping distance. So basically, if the distance I have to go is less than the distance I stop, I'm not there yet. Once these two conditions are false, I'm there. So in that case, all I want to do is just not do anything. I'm already moving, so I just yield return null. When this basically it's like I choose a path node, I start to move towards it, and then until I'm there, I just do nothing. Once I'm there, I want to get the next one. So I go path. Oh, so now I should check to make sure that path is in fact non-null. If path does not equal null, because maybe I've only signed a path node equals path get next and pass the current path node. If path is null, it means I've only been assigned a path node. So once I get there, I'm going to assume you want to like forget it and maybe start wandering or something. So if path is null, I'm going to set path node equals null. So the behavior, whoops, that should be an else there, like so. So basically the idea here is if you assign a path, they will stay on the path and just loop on it. If you assign a path node, they'll go to it and then wander or do something else, but they will not follow that path node anymore. If you assign both, then they'll go to the path node first and then they'll get the next one and go on the path. If you assign just a path, they'll go to the closest one and then go on the path. I believe that's it for follow path. See, I love that. What do we got? Like 18 lines of code for follow path. I mean, obviously it's probably going to bloat a bit in the future, but it's a good start. Let's save this. And so now let's demonstrate the typical behavior. So again, she's wandering. So if we go to AI, assign a path, she should go to 1, then 2, then 3, then 4. Let's see if this works. 1, 2, 3, 4, and loop. Lovely. Terrific. Let's try sending her first to 3, and then she'll start loop. Let's see if this works. She goes to 3, and then she starts her path, and we'll just make sure that it loops good. Yep, looks good. Looks good. And in theory, if we remove this path, so she only has a path node assigned, she should go to 3, and then we should see it null, and she'll start wandering around that position. Oh, nope, that did not work. Let's see what's going wrong there. Back to think. So if path or path node does not equal, I'll start to follow path if path node equals null, which is not the case. Oh, this should be or should it? While? I guess let's just do path node, because path node will never be null. So let's just make that while check only path node is not null. Yeah, I think that's the problem. There we go, and now she's wandering. Excellent. Now you might notice, as I did, that she moved much quicker when she was following, and that's because then she moves slowly. Yeah, that's because I'm not setting the speed. So right here in wander, I go agent speed equals walk speed. I should do the same up here right at the beginning of follow path. There may be conditions where you want to follow the path at run speed or something. We'll get there in time, but for now I want to set that walk speed. And turn speed is being set right in start, so that's fine. And you might notice I'm getting a little bit lazy about my null checks on agent. You know, when it's a problem, I'll fix it. Let's see here. So now she should walk. She should move a little slower even while she's path following. There we go. Very good. Yeah. And as well, because of the way, right. So now, one thing that might be worth doing, I just removed the path node there with delete. We might want to be able to assign path at runtime. That would be great. That won't work right now if we start wandering because there's no way to exit the wander. So you see she's wandering, and now if I go and assign a path to her, she doesn't pick it up because there's no condition for exiting wander right now. So that's one thing we want to do is address that. How are we doing for time? Pretty good. How long have I been at this? 1 hour 7. Okay, let's do one more thing and then we'll call it. So right now, in wander, it's a while true. So once I start wandering, I never stop. And right now, if I'm following a path and it's I will also never stop following the path. In the future, obviously, we want them to break out of these states. So right now, when you go into a state, it's an infinite loop. You will never exit either of these states. The only condition for exiting a state right now would be if I only assigned a path node. So that's not ideal. each state will probably have different conditions for exiting. Most of them will be like, do I see an enemy? Do I want to go into combat? But something low level like wander, almost any other condition, you'll want to break out of that. So here's where the state condition or state management becomes interesting. This is how I like to handle it. This works really well when I start nesting states, which we'll do in the future. We're already kind of nesting coroutines in the sense that think fires off sub-coroutines. So it's already scratched the surface there. But what I like to do is for each state, declare a local function that is like returns true as long as I should stay in this state. The nice thing about doing it as a local function is you can call it in multiple places and you've only defined the logic code once. Let's say there's 3 conditions that would exit a state. Every time you want to check it, you don't want to go if these 3 conditions are true, because if you add one, you've got to find all the other circumstances, yada, yada, yada. So it's nice to be able to say, okay, I'm going to define a function that returns and make it a local function so it doesn't clutter up the class. So, code speaks. I could go on all day. So let's just say we'll want to do this in wander. So I'm just going to define a local function. And basically, it's very similar to writing an ordinary function. You just do it right in place. So I'm going to go bool should continue, we'll call it. Takes no parameters. And it returns true, like so. So right now, this is a local function. So here in the while statement, I can go while should continue. Right now, this is effectively the same, but you can the takeaway here is a local function, and while and this calls it. So while this returns true, which is the case always right now, continue wandering. If there's other points in this state when I want to check that, like so, for example, right here, while I'm going to my wander destination, I should also check to make sure that I should continue. So if I'm interrupted with something like I spot an enemy or whatever, I want to immediately exit, right? So I'll go while wander time is greater than 0 and should continue. And here, just for clarity's sake, I'll put equals true, and I think I'll do the same here. I usually like to dress this up as much as possible for clarity. Like so. So now when should continue equals false, I will immediately exit my wander. Even though I've chosen the destination, I'll break immediately, every frame. And that's about it. So the condition that I want to check here is return these 2 conditions here. Path, so I put them in parentheses so they're grouped. Path equals null and path node equals null. So while both of these conditions are true, I should continue wandering. Now, if I assign a path at runtime, I break wander and start, or path node for that matter. Let's give it a test. So I start with nothing. She wanders. And then at runtime, let's throw path node 1 at her. Doink. There she goes to path node 1. Because it's just a path node assignment, when she gets there, it nulls, and she resumes wandering around that position. And at runtime as well, I'll throw a path to her, and now she starts following the path. So obviously I might have functions or, calls in code to assign it. I wouldn't drop it in the inspector in the game, but the point is you assign a path. If you did it in code, it would work exactly the same way. There you go. Wandering and following a path with a Nav Mesh agent and a nice little state engine using Unity coroutines. That is pretty much what I wanted to accomplish today, so I'm quite pleased. Thanks for being with me, and we'll see you next time.